So, uh, welcome. My name is John Pritchard. I'm a graduate student here at Iowa State, working on my PhD in electrical engineering. And I work in the high-speed systems engineering lab, which is with Dr. Mani Mina, if you're familiar with him. Yeah, so if you take 185, I've probably seen you. But if not, hopefully I see you soon. So today we'll talk about how to make a really cheap PCB. So one of the cool things about breadboards is that you can plug in all the components and test it out. If you want something solid, reliable, and permanent, I guess you could say, meaning something you could continue to ship out and maybe even sell someday, you'll want to follow a process like this. So the main message that I kind of want to get across today is that this process, what I'm showing you, isn't emphasized well in class, meaning no class, as of right now, teaches you how to design a PCB. They teach you circuits, but not how to actually make one and get it ordered. So we think it's important in the high-speed systems lab because even if you're an engineer who just does the design and doesn't actually do the design of the board itself, it's good to know the whole process from beginning to end. That way, as a designer, you can make decisions and know how it affects the board in the end of it, right? So that's our main message, is that maybe this is important for you. So what I'm going to show, we're going to show you how to use a free software called Eagle PCB. It allows you to put in a schematic, the circuit that you want, and then use that to create a physical board, something that you see that's being passed around here. And then finally, after you've created that physical board, we're going to show you how to convert it into a standard industry format so that it can be printed in any of the companies that print them. And ours will do for cheap. Like I said, this is screencasted right now, so if you miss something on this, don't worry. I'll be sending a link if you put your email down for this to download this presentation. All right, cool. So let's get right to it. So imagine an application in which you want to take your battery, your car battery, as the source, like the thing that's going to power your electronics, and do that, and power your electronics. Sometimes the electronics that you have that you need, for example, like an LED strip or something like that, it may not be powered at 12 volts. It may be powered at 5. So we will need a circuit that can convert that energy into 5. So to step 12 volts down into 5 volts. So that's the circuit we're going to create today. And we're going to show you how to design this chunk and get it shipped out so that you can use your car battery to power electronics that need 5 volts. All right. So let's do it. So the first thing we're going to do is open up the browser and download Eagle. So Eagle PCB is a software that allows us to put our design in a schematic form, then port it out to a layout form, which is like the physical board. Then we can convert that layout into a industry standard format called Gerber files. So the first thing we'll do when we get into Eagle, after you've downloaded it and installed it, is to create a new project. We're going to call this one Cheap Board, because we're going to create a cheap board. So right click, do new schematic. It opens up a schematic window. Then we'll turn on the grid because I like the grid. Now we're ready to start putting our design in schematic form. But really, we haven't really figured out this block here, the voltage regulator block. We haven't figured out what circuit is going to go inside there so that we can put the components in our schematic. So what we'll do is go to digikey.com, find the right part that converts 12 volts to 5 volts, and then work with an application circuit provided by the datasheet. So the particular circuit we're going to look for right now, the chip, is called an LM7805. It's a popular linear regulator. So here's the device. We're going to take a look at its datasheet. If we scroll all the way down to the typical application circuits, we can figure out how to create our circuit. So here we go. Fixed output regulator, that's us. That part in the middle is the LM7805. So now we're going to go into Eagle and add that part. So in the search bar, we'll type in the part number, and we see that we have several different options to choose from. Each option is the same regulator, just with a different footprint, the physical outlook. So if we go back to the DigiKey site, we can see that the package, the case, is a TO220-3, or a TO220, but using 3 pins. So that's what we'll use. We choose the TO220 package. Now we need to add the capacitors. So again, there are several different packages to choose from. We're going to choose a surface mount component, what's called a 1206 package. The 12 stands for 0.12 inches, and then the 06 stands for 0.06 inches, and that's the length and width of the package. So we go back to DigiKey, the product index, capacitors, and the ceramic capacitors link. Now we'll filter by choosing the value of the capacitance and one in stock, because we want to buy it now. That'll be all we'll filter for now. So now that we've gone that far in the filtering, we'll now only select the package type that we want. We chose a 1206 package in Eagle, so that's what we'll purchase. Alright, several still exist, so let's just choose a cheap one, 23 cents. It's actually relatively expensive for it, but hey, we'll take this. So that'll be the capacitor we choose. We'll then change the value of the capacitance to reflect what we'll actually install, or populate, if you will. And then we can't forget our ground. Alright, now we'll connect all of the pins. And now the circuit elements that we wanted to place are complete. The only thing left is a physical interface to this circuit. So what we're going to do is add 2 sets of pin headers. This will be our input and output ports. So pin headers, essentially 2 thick wires that will be popping out of our circuit. and this will allow us to connect it to whatever we want. It's always good to have text to show what the input and output is going to be, and just to give some notes to the users. Somebody else might want to use your schematic someday. Save it. It's always important. And what we're going to do now is switch it into the layout. So that button we pressed just now was the create or generate a layout from the schematic. So it took the components that we had in the schematic and converted it to its physical form in the layout. So now we will place our parts accordingly in a very organized format. And the yellow lines represent the connections that need to be made. They're not actually made yet, but it just indicates that this is what connections need to be made. And if you move the component and then right click, it'll rotate it. And that button we pressed to get rid of some yellow lines optimizes the distance from pin to pin that need to be connected, just to clean it up a little bit. So we'll now start routing, and we'll change the width of our trace. And now all of the nets that need to be connected will be actually routed. Those red lines indicate copper, so those are copper strips that are connecting our components to each of the components. We'll move this into a more compact form and adjust the board layout. Excuse me, the board dimension. Alright, and this is it for the layout. For now, anyway. So we'll save that, and our next task will be to first remove the values from what's shown on the board, because we don't need those. We just need the labels of the parts. And the next step in this process is to convert what we have here in layout into an industry standard format called Gerber. One of the easiest ways to do this is to go to sparkfun.com and from their tutorials retrieve the CAM processor job. So it's this file that has the settings that we can adjust to convert from the layout format to the standard Gerber format. So we download that and place the CAM file in our working directory. We'll use this file as our foundation for the job, for the CAM job. We'll have to edit it a little bit if we want to use the particular manufacturer called OSH Park. So in this case, we'll load the processor, the CAM process that we just downloaded, and then we'll make some edits. The first edit we'll make is the deletion of the top paste. And then we'll add another layer. So here it copied the top copper. Then we're going to change this to board outline. And then we're going to change the extension to .gko. And from the layer list, we'll only select dimension. And now this is our board outline. So we'll process the job. And now all of the layout format from Eagle PCB has been converted into its industry standard Gerber format. We can double check that by going to our working directory and show that the files were generated. So then we'll select those files and send them to a compressed folder so it's all compiled into one zip. And then name it to our liking. The final step in this process is to go to oshpark.com. This is a manufacturer that will take designs that we have in the Gerber format and print them on a PCB, printed circuit board. There are many manufacturers that do this, but this one seems to me to be the cheapest. Maybe there's more, I'm not sure. So what this program is doing currently is taking in the board that we sent, processing it, making sure that the specifications it has, meaning the manufacturing specifications, match the design you've given. So if you have trace widths that are too thin, there will be errors. Or if you didn't export to the Gerber format in the proper way, you'd have errors then as well. Alright, it seems to have processed correctly. The board image seems to be similar to what we gave, and it's only $3.25 for 3 boards. That's really cheap. Apparently it's $5 per square inch, so as your board grows in size, so does the cost. And the minimum order is 3 per order, so you have to buy at least